Hey, welcome to Coffee Compiler Club. It's small group today because we're all in the mid-Christmas season area. Here today to talk about compilers. And I guess everyone else is old hat. We're all going to be recorded live on YouTube. And that's it for the spiel here. Oh, here's Aaron. Anyone have something to start, or I'll tell you my woes with porting ecstasy to Java for a while because it's compiler related. So it sounds like it's a good place to start. You're
Yeah.
Say again, Cameron.
I'm listening.
Yeah, okay. Yeah, so here I am trying to port ecstasy to Java, and the one of the things ecstasy does is it has true generics. So there's an actual type. There's no type erasure. So Java just throws away the types under the hood. And if you pass Java C, it doesn't hardly mean squat because the runtime has to check all the types again anyhow. And there's just casting everywhere. Okay. It also means, for instance, you can't make a new array of a generic type. Instead, you have to call like array.new instance and give it the type somewhere, but you have to have the concrete type, and the types are all erased. So in ecstasy, you carry the type along as an actual value. So somewhere in the world, I tuck away the value from the type, and then I can hand it off to array.new instance and get the right types of things. And somewhere in there, oh, and then the other thing here is that technically there are no primitives. So whether or not you have a primitive like a Java primitive is up to the implementation. So I'm busy trying to have arrays of longs actually have Java lowercase longs instead of uppercase longs, and do the obvious thing for car arrays and bytes and all that kind of stuff. And then the genericity of ecstasy means that I can make an array based on a type that was passed in the ecstasy language, which the Java language means I basically passed the dot class of the thing. I have to go make an array out of it. And arrays in ecstasy can be resized, so you're really making an array list. So I have all these mappings going on where I take an array from ecstasy, make an array list, squirrel away the type of the body of the array, go ahead and make the Java version of that correct flavor of it, unless you're a primitive, and then I remap you to a different subclass at the Java side that has the primitive longs or primitive cars instead of a generic array of persons or animals or whatever the hell it's going to be.
And it's probably worth talking about some of the rationale behind it too. So basically, our array type has a couple different flavors under the hood. So the array list is one of them. You could conceptually say that slice is another one of them, right? Because a lot of languages, like if you used Go and slices, it's like putting your hand into a blender over and over.
Yeah.
Because it's like, yeah, and I haven't used Go much, so I'm probably being a
they
little...
said the goal was that you could write stuff to take slices, and if somebody handed you an array, you would just not notice that the
that's not
slices would be the
actually how
same API as the array, except it didn't work out that way.
Yeah, at all. Like, so you have two APIs now for everything. You have an API that takes a slice and an API that takes an array, which I kind of thought that they knew to avoid that. And then they like made it so it was impossible to do that. And I don't understand where the disconnect was.
I mean, if you look at the really early documents, they're like, this is a thing that we should avoid doing. And then
they did it.
And then they did it. Yeah.
Yeah. So the idea is, though, it's kind of a hotspot-like thing in that you realize that I have this thing that could be Jekyll and Hyde or Jekyll and Hyde and Bob and Jeff, right? So we have immutable arrays, we have fixed length arrays that are not immutable, meaning that that's like a Java array.
Yep.
Then we have like array list. And then we have like slices. So it's like there's all these different personalities of array. But what you realize when you actually get around to using the code is there's only a few places where you have a piece of code that has to deal with more than one of them. So even though the array itself could be Bob or Jeff or Sue or Jekyll or Hyde, it's always Jekyll or it's always Sue, right? It's like, except for like 3 methods or something, like I'm making numbers
Well,
up, so
it pops right up in the test cases. So
it
if you
should, because that's
if
what
we
test
defeat
cases are
those
for.
test cases, I'd move on to other things and have to come back, but it's right there in
Right.
the test case. So first up,
It,
that's what I'm dealing with, the generic version.
it's also worth thinking about the difference between as the program is running, it can be A or B,
Yeah.
versus as the program is developed over decades, it could be A or B. There's a lot of times where at no point did my program have the thing be both a linked list and an array list. But there was a moment when I went, oh,
Yeah.
this thing is being non-performant. I need to replace this with a different data structure that's not the dumb linked listy thing, but the actual smart hash table-y thing.
Well,
And I didn't have to change all of my code.
the
I didn't
challenge for
change
Cliff is very
the
simple, which
API.
is he's got to handle the, it's been 40 years, it's always been the array list style, and now on 40 years plus 1 second, suddenly someone in that same place needs it to be something else. Right. So if it ever has to deviate, if it ever changes from Bob to Sue, it has to be handled.
Has to be handled, yeah. So I'm trying to hand something to the JVM that he can regionally optimize, recognize that it's always the Hyde and not the Jekyll or whatever flavor it is, and do the right thing. And then if you ever
So-
flip and become, oh, you're both a Jekyll and a Hyde, and you flip back and forth, the JVM will just handle it, and you'll switch to the low performance. Everything's auto boxed. Everything has to take layers of indirection to get out of it. But if you're polite about it and just use array of integer or whatever it's going to be, he'll do the right thing. That's the goal.
To what extent is the implementation I'm writing ecstasy in Java? And to what extent is it I am writing an ecstasy compiler that produces JVM bytecode? And the
Yeah,
fact that the
I'm
compiler is
actually
written in
using,
Java is kind of irrelevant to the fact that you're turning ecstasy code into bytecode.
you broke it really bad for me, and I don't know if it's my end or your end, but I got the question. So yeah, so I am reading the output of the ecstasy compiler, so it's already been type checked, parsed, type checked, and whatever other annotations go on. He's handing me an AST. I am trying to produce Java, not Java bytecodes, so that I don't have to debug my Java bytecode generation. And then it's a JVM, so I don't have to do the code gen, I don't have to do threading, I don't have to do GC, I don't have to do a bunch of things. That's the reason you use JVM. So I'm writing Java out, and the Java is actually reasonably readable. I could actually probably, I think I've shared before, I can share again the reasonable Java code that comes out. And then I'd have to probably squirrel away and run back a version because I'm currently broken because I'm mid-hack. And this is what I was going to whine about, was I did a thing that I finally got enough generic that I could auto replace generic array with array list of longs, which I have one written already. So it's not the actual Java array list. It's Cliff's internal array list of longs, fine. And then the iterator produces a lowercase long. And so now I need code because it says for long of I from iterator, and the old code was returning me a boxed long, and Java was auto unboxing. And so your long I index value was then being fed into a Lambda, and it was effectively final as part of the body of a Lambda. Now I'm returning a never boxed value. So it's a for loop long I from an actual long. It gets changed every iteration. It is no longer effectively final by removing the auto boxing. It's just like, no, you can't hurt me this way. What the hell are you doing here? Let me see, somebody else say something. I will see how fast I can get this to a demoable spot, because right now it's just going to hit my to-dos because I'm in the middle. And I need to stash everything and unwind, and I can do that in about 5 minutes here.
Yeah, if you let me share my screen, I'll pull up.
Is it not done? Let me go share screen here. Hang on. Try now.
Sure. Share screen,
Okay, let
advanced,
me just
portion of
stash it,
screen,
literally.
ignore the porn. All
No,
right,
not the porn.
all right.
Took over my screen.
I don't know if that's a good size. Let me shrink it down a little. So the idea, and again, array is actually, quote, implemented in ecstasy, although in reality, of course, that's fairly meaningless because it's one of those, even though it looks like it's not a primitive, it's one of those things that you assume any legitimate runtime would replace with a a native implementation. In fact, our proof of concept does that. And obviously, Cliff is doing that. What I'm looking for, though, is the mutability. So what you see is won't have a language server yet, unfortunately. So every array has a known internal mutability.
You're treating persistent data structures as a different mutability class than immutable. Interesting.
Right, because immutable, well, so keep in mind that ecstasy itself at the language level, runtime level, has deep immutability. So this mutability is actually separate from that. This is kind of like, I'm an array, I define my own style of mutability, where this one says, oh yeah, I know I'm actually deep ecstasy immutable. This one says I'm persistent, but I can hold on to things that aren't immutable. So I act like a persistent data structure, but I don't enforce deep immutability. This one, like I said, this is basically the Java array style or the C array style, minus realic, in that, I have a known length and it doesn't change. But the things in each element can change. So it's not a persistent style, it's not a constant style, but it's a C style. And this one is the array list style, which is, extremely common. And in fact, in Java, what you often see is that people build an array list just to convert it at the end into a Java array. So that they can use something as an array, but build it. So, but those four aren't the only Jekyll and Hyde aspects, right? Because the slice itself, so slice is it's an operator among other things, and it is defined on an interface, sliceable. But the idea is that you give it a range of indexes, and it returns you back an array. Now, obviously, you don't want that array to necessarily be copied, particularly if it's immutable or persistent or whatever. So under the covers, we use a concept called an array delegate to basically hide that potential reference, so that I could have a slice return that might be or might not be a reference to the old array. You ready, Cliff?
Yeah.
Yeah, so that's kind of the background for where the complexity comes from.
So I assume if I have some big thing that I'm parsing and I make a bunch of slices, if any one of those slices, even if it's only carrying one word, sticks around, it's going to prevent the GC from collecting the entire buffer.
In theory, it could, yes.
So up on the screen is ecstasy code. I'm trying to transpile to Java. It's doing some simple recursive algebra thing for counting permutations. I'll show you the output in a minute, but it does the obvious thing, gives you all combinations, 1, 2s, and 3s, or whatever your argument count is. And so it does a lot of fun stuff with arrays, like here's a recursor call to permute with the item count lowered by 1. You get a pattern of a doubly nested array. You get a result with an empty list of doubly nested arrays, and you do this walk the prefix as a range over the items. You get out of the pattern, you get a list of suffix patterns that you then make new versions by recursive calling yourself, blah, blah, blah. Okay, that's the code that's being transpiled here. So I just compiled, I have the compiler spitting out my code, so I'll dump it in the buffer. Here at the bottom is the execution, by the way. So that's the permute of 3 gives me all combinations of 0, 1s, and 2s. And the transpiled code says, you know, auto-generated, import every freaking thing, do stuff. Here is the permute code. This is the transpiled Java that comes out. So if items is less than 1, let me go and bring up permute on the right here. Right here on the right hand side, you see items less than 1. On the left hand side, you get the same items less than 1. If items is exactly 1, then I'm going to return you a new array of, oh, skip gold for a second, a new array long of 0. So array long is an array of longs, Java lowercase longs. And that corresponds exactly to the lowercase long array right there. And then the next wrapper out is the array of longs. So it's a generic array. It takes a type. This is the type instance. Gold could be replaced. It's a golden instance. Could be replaced with the word capital type or something. So the type of the body of the array is array long. And then the other version is just the empty array of the same thing.
So basically, his gold is kind of like what some languages call a prototype.
Yeah, it's a prototype. That's a good answer. Yeah. For me, it's being treated as it's the type of the object, which if I was to go ask for the Java type of the object, I would take the gold instance and call get class. But because I have an actual instance, I can do virtual dispatch on it, which I do in places where you do these things. So here's the recursive call to permute. On the other side, it's the recursive call to permute right there. You can see they look pretty much similar other than the typing has changed. Then here's result, which is an empty array of array long. Here's the result right here. Pretty much same thing. So the for loop here is this is the problem for me running over items. I go over here, I have a for loop which says, give me a new range from inclusive to exclusive of 0 to items from prefix. The range object internally has the Java iterator implementation, and it returns me a boxed long because I have range objects which range over many kinds of things, and the things you return from the iterator vary by which range you have. So I have to return a generic object in the Java land, so I return a boxed long, which means that the expanded code here for prefix takes a boxed long as a thing which would otherwise be mutating and then unboxes it into a private variable. It's effectively final. So 2 lines down here, result add new array long. Let's look at here's the XC code for this guy. I'm making an array new int of length of items, and I'm passing it a function, and that function is how you initialize the array. So I hand you a function, and then I'm going to iterate over the elements for the length of the array and fill in all the items. You'll notice prefix is being used here as a value that comes from outside the lambda expression. So the Java lambda expression is right here for the same thing, and you'll notice prefix is in there, which means for a Java lambda, prefix here has to be effectively final. So the change I just got done doing was make the new range here return me a lowercase long, which I have to do by inlining the iterator manually, which I can do because I know the strong type. So I'm manually inlining the iterator, and it says, for long prefix equals 0, prefix less than range.low, or range equals range.low, less than range.high, prefix plus plus. It's no longer effectively final. I'm just now having to deal with go find where it's defined from inside the lambda and make sure it's effectively final. Oh, it's not. Insert a copy to an effectively final variable. It's just like, oh, geez. What the hell? And all that was just in support of having this ability to make an array based on its type. And Zoom is trying to complain at me. Why is Zoom complaining?
And it's certainly easier to reason about things if they're effectively final. But
Well,
right, but closing over a mutable thing inside a lambda is really useful.
not in Java, it isn't.
I'm just like, but why can't Java do the same obvious thing? I'm going to do a very deterministic, straightforward operation. I'm
Right.
just going to make a copy of the variable. as close as I can to the last mutation point.
And since it's a primitive, there is no other thing.
Yeah, right. Yeah, yes, yes. And in fact, I could insert final. I have to use the word final though. Final var. Oh, I don't. I looked this up. I can use the word final. I don't have to. Var $F prefix is equal to prefix, and then go into the body of the lambda and rename prefix to $F prefix, and the problem will go away. And that's this morning's grief. And all of that. Oh, we can go look at this guy too here. Let's see here if I have. Yeah, here's the code that causes the problem. Somewhere up in the world, somebody says this in ecstasy code: go make me an array of an int array by calling create. Secretly under the hood, create gets passed a hidden extra variable, which is the type variable. So create here, as defined right here, because it has a generic type, bracket T bracket, straight out of the Java land generics, there's a hidden extra variable for T. It's as if I wrote in here T type as an extra variable. I got passed you actually no, it's I
Type T.
passed you type T.
Right.
Yes. And then
actually,
when I
that's
call
how
a new
that's how
array
it
of
compiles.
T, well, because he's generic, it's actually being passed as an argument to the constructor. And my implementation for array, which, let's see here, this is pre-big hack. My implementation for array takes a gold value. So here's a version of array. This is Java code on the left that I have as the intercepting the ecstasy definition of array with the Java version, and he takes a gold, but you want one with the mutability. So here's one that takes gold and a mutability, and it's to do, but all he's going to do is honor the mutability and take the array and do the right things. Here's one that takes that long function that just applies the function. But you see I'm using array.newInstance of the gold.get class. So in order to do this where I'm looking for arrays of longs, I can't have my array body here be a Java generic array, because that's an array of objects after erasure. I actually need longs. So this code won't give me an array of longs. It'll give me an array of lowercase longs. And my cat has decided to join the fray. This was part of our very fun Christmas where the cat shredded the tree and took all the ornaments off, which we kind of knew was happening, but he was pretty damn good about it. And he's purring up a storm and trying to be like, I'm such a good cat. And then he's biting my desk and he's going to bite me in a... No, he wants to play. He's just still a kitten. No, 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 no.
Okay, so the cat likes ecstasy code.
Yes. Ow. Hey. It was a play bite on my elbow. Fine. Anyhow, so lost in the confusion. Oh, the generated code for this is probably no good here. I wonder if I can have that lying around here.
For this test on the right?
For this test on the right here. Yeah, let's go. What did I change over there? Oh, I changed it. Yeah, I don't want to do that here. So test misc has, it's not the test on the right, but it has something similar in here. I swear, actually, the TCK, which, let me see if I have that line around.
I gotta say, compiling ecstasy to Java does make clear the sort of arguments for where ecstasy feels more expressive for things you would like to express.
Oh, I saved the damn thing. Hang on. I did non-ecstasy hacking here to make it look like as if. Let's see what happens here. Yeah, no, that's the middle of me doing more hacks to get this problem fixed. I don't have this one lying around. I have something similar here somewhere in this giant pile of, this is a run together set of tests. This is not the TCK, which are kind of polite. All right, I'm not going to find it right away. There's a version of that failure in here. This one is running and doing something sensible, but I wonder if test mod I faced took it. No, it has other issues that were exciting, and I turned off the issue that was causing me grief. I find. No, I don't have it lying around. Sorry, I was going to try to show you where this thing compiled to, but it's currently
Yeah,
broken, and that was with the mid hack. I'd have to.
and the challenge with those types of kind of generic behavior slash you know, friendly language structures is any one of them in isolation is obvious and easy how to optimize. Right. It's the combinations that get hairy, right? So they're all designed to be optimizable. But you know, the as with anything, there's a performance cliff somewhere. You can always find a performance cliff in any language. We just make it
You just
easier.
keep calling my name, I'll show up.
Yeah. There you go. We just make it easier to find.
That's one of the issues I've had the more I learn about the V8 JavaScript engine is I keep thinking I've got a reasonable mental model of what is and is not optimizable. And then I watch the V8 people optimize a thing that I did not think was optimizable.
Ah. Yeah. You know, way back
Like
in the day when C2
the
came
heroic
out,
optimizations they do to try and short circuit the prototype chain so that you don't have to follow 6 pointers to find out that a function does not exist.
right. You know, back in the day when people didn't understand C2 very well, I had a lot of conversations with folks about how to change their code that'll optimize, and they just thought it couldn't be done or didn't understand. And then they had some straight up conversation. No, do this stupid thing. And they would do it. And, oh, look, it's 2x faster. And like, oh shit. You get a
I
mental
wonder how
model of what
many
the
of those
optimizer
tips
does.
can be baked into a linting tool. So that the compiler says, okay, you did this thing that looks like I could do this optimization, but I can't because of this weird case. Can you please tell me that you're not doing the weird case?
It's like
so that I
finding
can do the
bugs.
optimization I would like to do.
Right. Well, you get things like doing string concatenation in a loop will give you a warning. Hey, did you mean to use a string buffer here? Right. You know, Clippy pops up and says, surely you meant a string buffer here. Or a string builder.
Right, but there's nothing that prevents you from just turning that to a string buffer for them, right?
Well,
like that feels like one you could actually do safely. Whereas the like you said .map. Now I need you to actually promise me that what you meant was do all of these things, not run the whole list 5 times.
And you'd be much happier if you fuse the loops. But I can't make that clear myself. Yeah, I don't know. Like,
right. There's times when I want to warn you and be like, the reason I can't fuse the loops is because could you please add a annotation that either says, no, I meant to do this, don't fuse the loops, or no, fine, fuse the loops.
Yeah, I want to say IntelliJ doesn't offer to rewrite my string concatenation loops. I would think that if it could be done, he would have offered, but maybe he does now. I haven't checked that one in a while.
I kind of wonder if C++ can do something like that with the string class type. Because sometimes in the loop, I know it's going to be like 100 bytes or less. I just, I don't use like a string builder. I just do string plus equals. So I wonder how optimizable the C++ does with how much optimization C++ does that.
Way back in the day, I did string concatenation optimizations in a C compiler. But that was on a compiler that's probably dead now. Oh, look, it brought in last week's comments. It maintained the group chat. It's just a continuous extension weekly. That's very interesting. And I know I've talked to a guy who was trying to do, it was on here. It was a Zen, I haven't seen him in a while, who was trying to do string concatenation optimizations in C2, and he was going about the wrong way. But there's hope that C2 does something there. But these are never making a string builder for you under the hood. They're not actually making a string builder per se. They're doing something with a private string builder like effect. I guess in the end, they need to end up with a single final string object that has all the right things appended to it. So they pre-make one with lots of blank spaces, and they keep filling in and filling in and filling in, and then they have to chop it to the right length. So I don't know what he ended up with.
Yeah, I'm just reminded of a project that I was brought on way back in undergrad. And they're like, our tests are taking forever to run. Can you help us with our performance problems? And I look at the profiler and it is spending 99.99% of its time in vector resize and 0% of its time in all other code. And basically what they're doing is running through a loop saying, oh, I need to append a thing to the end of the array,
Yeah.
allocate a new array, copy all of the elements
Yes.
over,
Yes.
add one more thing.
Yes.
And by just tweaking their code slightly so that every time they overspilled the array, it doubled in size rather than
Yes.
getting one longer.
Right. Well, it's a classic array list, array doubling trick.
Big,
Yes.
big O
Yeah.
is not the enemy you want to choose.
Yes.
Um,
It's not worth fighting that one. Yes, it's not worth fighting that one.
And it turns out now that's totally irrelevant because MATLAB has changed the way it works with arrays, where it just decided that you want new arrays to be 1.5 times the length of the old one and not one longer.
Yep. Yep.
So that entire set of optimizations is no longer necessary because they just changed what MATLAB vectors
right.
are. But
Use an array list under the hood, and they should have been using one all along if they're going to have resizable arrays in the first place. Yeah, fine.
so you can play those games with strings where it's like there are times when no, I'm formatting this string and I know the string needs to be exactly this size and it's never going to be another one. Don't make it 1 byte longer than the current thing. Or there's the no, I'm in a loop appending to the end of the string. You should be doing array list games.
Yeah, yeah.
I wonder if there's a reason to choose 1.5 instead of 2.
Oh, you don't get such a sharp memory cost jump. It's asymptotically the same. It's some log power half to constant factor slower. You get more resizes, but you don't. It no matter on the small end, but on the big end, you went from a 100 megabyte array to a 200 meg or to 150 megabyte array. And you jumped again from 150 to 225, or you jumped from 200 megabytes to 400 megabytes. So the jumps get bigger. And as you run out of memory, the big jump gets sort of painful, and 1.5 lets you ease into it a little slower, and you maybe don't run out so harsh.
I kind of don't think that's relevant on Windows and Linux. Like
It is
embedded,
for everybody.
probably.
It's big O. No, it's big O. You have a limited amount of memory. If you do doubling and you pick wrong at the point where you do the final doubling, you'll run out or not. And 1.5 will have you get a little closer to the total consumption of all memory before you run out.
But that's the thing, because on Linux, you don't actually, or Linux and Windows, you don't actually use the memory until the memory is actually touched.
No, this is assuming you're actually touching it. There's no point in doing this unless you're touching it. You're adding, and it's getting bigger and bigger and bigger. You're going to approach the limits of your memory. If you double, you'll possibly run out before it would fit. It lets you squeeze a little bit more in before you run out of memory.
Yeah,
I have totally done this for exactly the same reason.
But fundamentally, you always need on the order of twice the buffer size.
Yes, you have
And
to grow
that's-
geometrically. Yeah, not by
that's the
constant
challenge.
amount. Geometric.
So I did 2 things relevant to this. One is I once took the highest bits of the size, and then just that 1 bit, I just lowered it and added. So it wasn't exactly 1.5 because
Yeah.
the second time it would just also be half of the previous.
Yeah,
But
so that's
like
a geometric growth, and that's what you need.
yeah, that worked out pretty fine. But then I realized that around like 40K or 50K or whatever it was, it's just faster to mess around with memory remap instead of copying the array. So I just did memory remap after that cutoff, and then I don't care about the size.
So right,
If it's
so-
bigger than
so
this.
Then you're using the TLB and the hardware to let you effectively reallocate in place to keep growing, which is a fine thing to do, but that's not the normal spec you'd get out of most languages. So you had to dive below malloc to go to memory remap.
Yeah,
But malloc implementations often do use mremap, I think.
They might. I know that garbage collectors for large objects move them once to get them somewhere handy, and they never bother to move them again, doing a similar kind of thing.
Just out of curiosity, I mean, like this problem where the last doubling makes you run out of memory. I mean, that shouldn't be a problem because, I mean, you're not going to run out of virtual address space, right? And
Okay, so
unless you touch
if you touch virtual memory, you die the death if it's too slow. So there was a time when virtual memory made sense. These days, pretty much if you hit swap, you're dead. So don't bother. You should
but
just
the
throw
thing
out
is, like,
memory.
let's say you say you call map and you allocate it too big virtual region. I mean, unless you touch all of these pages, the page frame allocator is not gonna run,
Hey,
right?
I'm on meeting. Yeah, grab your stuff. Yep. Okay, sorry.
Like the page fault, there's not going to be any page faults and there's not going to be any swap, right?
So the reason you're grabbing the memory is to use it. And if you could fit in your current RAM and not in the doubled overflow, you're right. And if you're going to go the doubled overflow, you're dead. So maybe you're right. You could be. So this is a case of, it's not swap, it's you never touch it. It's just virtual memory that you never actually touch. Although if you do run into it, then you're gonna swap, and then then life sucks for you.
So my case for swap is very cynical, which is I have found that when you've got something that is leaking slowly,
yes, okay,
that it creates things that are in memory that never get freed and the garbage collector can't actually let go of because it's not actually garbage. You've got a pointer to it, but also you're never going to touch again and you don't care. Sometimes swap can be cheaper than finding and fixing your slow leak if you're going to reboot your service every 2 weeks anyway.
Yeah, this is the whole missile guidance thing. You know, the garbage collection is that it blows up.
yes. And
but yeah, swapping on memory you actually use is a loser's game.
Okay, so the issue with that one is if you need to do a GC cycle and the heap is swapped out, GC is typically fairly random, so you suck, yeah. And I have seen people do papers where they said, we think that this is a linked list of forever, and you're going to run out of memory. So instead of running out of memory, we're going to put we're going to chop the list, reclaim the memory, put a token on it that says a sentinel that says if you touch this, we'll throw out of memory. And so yes, exactly. It's like
I secretly deleted a thing that you actually needed.
Yeah. They're going to throw you out of memory anyhow. So instead of throwing out of memory, they stop and they secretly delete a thing that's reachable.
It's an out of memory null pointer special null pointer.
And it's an out of memory null pointer special. Yep.
That would drive me crazy.
That is terrible, and I love it.
Excellent.
I would hate
think it
for
ever hit
anyone
any
to
production
try to bug
server,
that.
but it kind of makes sense, honestly, given the use cases I see.
I was curious, Yorick, you had been working on something and you had some walls. What ended up happening?
What specifically? I mean, I've been working on parallel code generation for LLVM.
Yeah, you're fighting LLVM being terribly slow on terribly badly machine-generated code.
Yeah, and I was thinking about the one before that, where I'm trying to
the other one was incremental compilation. So I I've not done anything for incremental yet, because I felt that was something I just need to think about a bit more for like a couple of days. Basically, I've learned that when I have these, how you call them, these points in time where you basically have to choose, am I going to go left or right? What I find is, at least frequently in the past, if I just pick one, I will implement it for like 30% and then realize, oh wait, that's actually not great, let's go back. And I'll pick the other option, implement that for 30%, and then realize, oh wait, actually that first approach was better.
Yes.
And so my sort of counter strategy is whenever I reach those points, I'm just going to let it sit for a couple of days. Just do something else, and then figure out later, based on having read more about it in the background, figure out what to do. So incremental is one of those things, and I figure, hey, you know what? Even if I'm going to do incremental LLVM, parallel generation is something that could still be beneficial, because I figure that whatever incremental scheme I'm going to implement is initially not going to be terribly good, in the sense that it will probably invalidate caches a bit more eagerly than necessary. And also because the process of generating object files is embarrassingly parallel. Like the way it was structured, it's the way I had initially structured, it's basically each module in my IR is lowered to a module in LLVM that is then processed with LLVM's passes, and then you generate object files. But that process didn't really share, I mean, it shared data, but in a read-only fashion. So it needed some access to like type information or the IR database, but that's all read-only. And so on the surface, that is very easy to parallelize. You generate everything individually. And as far as I could find out, LLVM doesn't really do cross-module optimizations in the first place. Like I have yet to find solid answers for this, but as far as I can tell, if you have a function in one module and you call it in another, and you run the inlining passes, it will not inline it. And that's based on the fact that everything is sort of scoped to a context. Mm-hmm. And I suppose in theory, if you have two modules in the same context, then maybe it could do it. But LLVM basically says like, hey, you can do things on a per thread basis per context, which means that then it wouldn't be able to do that, right?
I saw this behavior in Julia, LLVM jetting Julia code. It wouldn't inline cross.
Right. And I mean, it kind of, I guess, makes sense if you're coming from sort of the C land where some stuff might be pre-compiled, so you can't inline it anyway, you know, whatever. For me, that was fine because I am planning to do much of that work myself anyway. Like inlining something, even if I were to have LLVM inline stuff on top, it's something I would want to implement in my own front end, so I can apply other sort of language-specific optimizations on that. Also, the long-term thinking is I'm using LLVM now because it's the least annoying solution, but I'm hoping that by the time I have implemented decent optimizations and whatnot, a better alternative presents itself. And so I'm basically treating it as like a dumb code generator. I'm like, here's some IR, generate some object files. Don't try too hard about optimizing it.
Well, change backends to like TCC for being faster.
Whatever, right? I looked at Cranelift. My conclusion there is it's better than when I looked at it a year ago. But better in the sense that it made a couple small steps. And the challenge I ran into there is that if you are sufficiently smart, it's probably not a big deal, right? So it thinks it was lacking was variadic argument support. Now, if your language doesn't have that, who cares? I don't support it, but I do have an FFI, and C unfortunately uses it. Like printf uses variadic arguments. Curl uses it heavily, so I had to support that. LLVM makes this fairly straightforward to do. In Cranelift, it's just not supported. You have to figure out how to do that, and the sort of work in progress backend for the Rust compiler, the way they do that is they sort of lazily generate the function signatures based on the call site, and then have Cranelift generate code for that, which the result is the same, but it's just a kind of different way of going about it. And it does sort of assume that the underlying ABI treats a variadic function with 3 arguments the same as a function with 3 regular arguments, like in terms of how things are passed on like the stack and all sorts of things. I think in practice that is the case, like it's the same, but it's this area is like it might not be. I don't know. But then there's other areas where Cranelift supports atomic operations, but it forces or at least the documentation states that it enforces sequential consistency, and there's no way to have, say, acquire release semantics. But then the code generation backend for example, x86 just translates it into a move because x86. But then on ARM, I think it does indeed use sequential consistency. So you end up basically paying a cost that in many instances just isn't needed. Again, not a big deal, but there were a bunch of these things. I was like, okay, I can do all this work. I can probably make this work. But I feel like I will be taking a step back, actually. Because the amount of, I was expecting, for example, the amount of code that I needed to write to be less. Because LLVM's API is quite boilerplatey. But I found that basically it's either going to be roughly the same or even more. So for example, in LLVM, if you have like you generate these type layouts for your structures, and then you say, hey, you know, give me the field number 4, and it will calculate all the offsets and all that stuff. Even if you're like index through multiple pointers, etc. In Cranelift, you have to do all that yourself. Which means that in practice, you still need to generate these sort of type layouts for your structures. Then you need to calculate offsets yourself, taking into account padding. Again, not a big deal. But it's a lot of these things that add up to the point where you're like, okay, you know, it's probably not going to be actually less work compared to LLVM.
Yeah, the reason I was mentioning TCC was just get your faster code gen.
Right.
But you still have to emit all that stuff.
Yeah, so currently I do not emit C. I think in theory I could. The reason I decided against that when I switched to LLVM was that when you generate LLVM, you have fairly precise control over, well, one, everything, but also debug info. So you can generate some bullshit function name and then say, hey, actually in GDB, make it look like this instead.
Right.
Whereas if you emit C, that's not possible. Like you can emit these line directives that the preprocessor will handle, but that just says this is this line in this file. That's it.
Yep.
You can't say, hey, this function that's called whatever, actually it's called this other thing.
You can't put dwarf debug info in a C binding?
Not in C source code, as far as I was able to find out. And then you essentially you end up with these weird things where because C it doesn't support I call like bidirectional, in the sense like if you have to declare type before you use it.
Yes.
And it's not smart enough that if you use it and then like the line below it, you define it, it's still like, oh, that thing is not defined.
Right.
So when generating C source code, you have to basically make sure that everything's pre-declared, so that it doesn't really matter what order you imported it in. A bunch of other things where I was like, again, you can make that work. I just didn't feel like it.
Okay.
Yeah. I got some stories, but I'll keep this short. So, like York said about LLVM, you can be very specific or precise. That's why I chose LLVM as my first backend. But then later, when I noticed how fast my compiler was going, I noticed that LLVM took all the time. So I'm like, okay, time for a new backend, which was the C. Now, there's a couple problems I hit. I thought that because in C, you don't have to declare the function prototypes, but it turns out you do, because if the parameter is not an int, it will complain for one reason or another, or it might do something weird. I can't remember the specifics because I just like fixed it right away. But I do remember not having the names of variables and not having the prototypes ready when I generate the function, being as two reasons why it took more than like a week or two to do the backend, because I had to like fix up all my code so that everything had a variable name and everything had, because in LLVM you could just say variable 0, 1, 2, 3, 4, 5, and you don't need names. And you could hold off on names until the very end when you debug, when you emit debug information. But yeah, so the other thing about generating C, is I wanted to have a bunch of temporary variables, and it would show up in GDB or GDB and LLDB. Like you'll see 100 debug temporaries.
LLDB?
Yeah. So what I had to do was
So what is
I
LLDB?
it's
I didn't even know
LLVM's,
LLVM had a debugger.
yeah.
It's LLVM's
They use it
debugger.
on Mac.
Okay.
Yeah. So the issue was like there's no way to say you don't want to emit the bug information. I noticed in LLVM I was able to, but it didn't work on GCC. So what I did was I patched TCC for if a variable started with a prefix, it would just skip the like emitting the GDB information for that. So yeah, when I distribute my compiler, I have a patch for TCC, and yeah, so that's about it. But it is it can be a hassle, but you get pretty fast speeds. But I mentioned to Yorick before that I think the biggest one would just be changing how he does his array. But I don't actually know how much effort that is, or how sick and tired he is of messing with the LLVM and cheating code and all that. Because compiler backends can get annoying sometimes.
Yeah, so there, sort of wrap that up. I have parallel code generation working. Interesting enough, I have yet to actually test it on my desktop, but on my laptop, which has 4 cores, 8 threads, it results in a 4x speedup, on 8x. Interesting enough, I ran some tests. It was like, okay, 1 thread, 2 thread, 3 thread, 4. And yeah, you can see it gradually get faster, and then it basically stops at the physical core count. I then also looked at CPU usage, and it just completely saturates all cores.
Yeah. You probably
so
out of memory bandwidth.
Yeah, let me see if I can actually very quickly test this here, because I have the thing compiled. I can't type and talk at the same time, but so that's working, and I think I then added also the ability to link with mold instead of LOD. Because my setup was that if LOD was installed, it would use it. Otherwise, just use the system linker. But then I figured, hey, might as well add support for mold because it's a bit faster. And there I found like the system linker on Linux is slow. I knew that, but I figured, hey, it's 2023, can't be that bad. It's bad. For my, my standard library, I don't know exactly how many object files it is. I don't know, 20 or something. I think the system linker gold would take something like 300 milliseconds to link, and then LOD did in like 70, and then mold did in like 30 milliseconds. So now it also supports mold and automatically picks that over LOD. Incremental, I'm probably going to start with next week. Just to give it some more thought. And in the meantime, we're trying to build a static site generator in my language, which is actually also surprisingly tricky. Because I really don't want to write a template engine. But that kind of creates some other interesting challenges for, how do I basically make a template? But yeah, so that's the sort of general state of it.
I was thinking about doing the same. So if you want to bounce ideas off of me on Discord, just let me know. But yeah, I got to do that.
So for templates, this might be an interesting topic because it's also compiler related. I really freaking hate template engines, like Mustache, Handlebars, all of them. I get why they understand, why they exist. I think it makes sense if untrusted sources are producing the template, like some designer, like Shopify, for example. You can write your own, little layouts for your web shop. There makes perfect sense to have this restricted template engine where you can, include some variables, do some looping and stuff like that. But the case of untrusted versus trusted input, the trade-offs are very different. Right? If you have untrusted input, you don't want somebody to write a infinite loop in their template. So what Shopify's template engine did last time I looked into it, this was years ago, they probably still do, you could do things like, limit loops to this many iterations, or I think that's some sort of cost model where you could say, hey, sort of give a upper bound to how much time we can spend rendering this template. But the issue that always presents itself with template engines, like every single one of them, they will either start out very simple, like Mustache, and they'll say, hey, this is logicless. People are like, this is great. By the way, can you add while loops or whatever? And then it spirals out of control. Because people say, hey, we already have for loops and while loops. Why not add break and continue and next and, whatever. And so you end up with basically a Turing-complete language inside your template, but it's an absolute pain in the ass to use because you can't just define a function. No, you have to define it in the host language and then register it. And
And
now
you have to put it in the HPP and the CPP. Yep. Yeah.
Yeah,
I
and
use
then
that language.
because the templates are always basically dynamically typed. So then if your host language is statically typed, how are you going to deal with that? Basically, my point is there, I really prefer generating templates with the actual language so that you don't have to reinvent this sort of half-assed way of doing code reuse in templates and things like, hey, I want to display this thing, but in this one area, I want to have it capitalized.
Do you have
Right,
an
you
opinion
like-
on
you just
format
do-
strings for templates where I just say brace some arbitrary code in my language, close brace?
So yeah, example there's like ERB in Ruby, for example, or PHP basically is that. I think those
Right, and you
are
can put
better in the sense that you at least have a actual language that you can use, but you're still sort of stringifying the two together. And you end up with these weird things where if your output is whitespace sensitive, then the position of the tags can influence that whitespace. So all these template engines, they have this mechanism where you can have some extra character somewhere to say, hey, strip the whitespace on this side or that side or both. It just ends up getting really fucking messy.
Don't use Python for your source language.
So what I have is I started this, make a site generator a while back, figured, okay, what are the libraries needed for it? We need Markdown, we need HTML generation, a bunch of other things. So those libraries exist. And there is, I have a library where you basically programmatically generate XML or HTML. This exists in many languages. Just using functions. So it's like, I want an HTML tag, call the HTML function. Or you want some child node, so just give it a closure and then it will process the body. But the challenge there is those APIs end up being quite verbose, sort of depending on your language. And they're also quite allocation heavy. So if you, for example, use, let's say simplest form is you just use functions and each function takes an array of child nodes. So you have a list, then it's UL first function call and then a bunch of LI function call arguments. But that means that for your list tag, you now need to allocate the array for all the list elements, an array for each list element, whatever arrays for their nodes, etc., right? So a simple list can end up allocating 100 objects, just so you can concatenate a bunch of strings together. And then the verbosity is where if you use, for example, functions and closures, so the syntax is something like a list, and I give it a closure, and then the body of that closure becomes the child nodes of the list. It ends up being more verbose, kind of depending on how your language handles closures and implicit receivers.
You got any examples of any of this stuff?
Yes, I can pop open a link. I can dump it in the doc. 1 second. I'll edit link number 2. Oh, Google Docs doesn't recognize that as a link, but That just shows an example of sort of how to, in this case, construct a very simple XML HTML element in this library.
Oh,
But so
yeah,
you basically, you start with your document and then you say, hey, sort of enter that document and then say, hey, I want an element with this name, enter that, etc. But the verbosity here is that each time you create a closure, you have to sort of pass in the context as in terms of what element it's operating on. So you see things like, then in this case is my function to like, evaluate this closure as the so within the element. But that means that every time you want to enter an element, you get this repetition of then closure with one argument, closure body. And that gets quite tedious. Now, I believe Kotlin does this nice thing where when you take a closure as an argument, you can say, hey, the receiver of this closure is X. And then if within that closure, you just call a function, I believe it will call it on that receiver. But then your language needs to express that, support that, which mine doesn't. But so this is sort of the trade-off with template engines where like you can have this sort of dedicated language and it can generally perform quite well, but you end up with this sort of programmer language embedded on it on crutches.
Mm-hmm.
Or you can get the full power of your host language, but it inevitably ends up becoming more verbose and perhaps not as efficient. The verbosity kind of is like if you do it in a Lisp, it doesn't look too bad, but it's mostly because Lisps are already quite difficult to read.
Yeah.
So yeah, this is sort of my current dilemma. Like
I
I'm
do
just
not like that comment.
I mean, I'm not saying Lisps are bad, right? I think it's quite clever how they work. But I think their syntax is a double-edged sword. Like it enables exactly what Lisp is good at, but it also makes it an absolute pain in the ass to edit without a dedicated sort of S-expression editor plugin.
Emacs.
I know what you're talking about. Lisp is great, close parenthesis, close parenthesis, close parenthesis, close parenthesis, close parenthesis.
Exactly.
I got a topic if you guys want to switch.
I was gonna say something about bandwidth, but I think swing through the link out was pretty good. Basically, if you keep adding cores and you're not running any faster, but your top says they're all busy, you're usually out of bandwidth.
I would
That
like to say
combination is out of bandwidth.
there's one more thing. Like I actually posted a link to the doc, the first link. The thing is, like, even if top says like all your cores are utilized, I mean, that just means that currently your threads are not being preempted, so you're not doing some locking or blocking system calls or things like that. But it doesn't necessarily mean that you're out of memory bandwidth. You could also be just you could have like stalls, just memory stalls waiting for. You could have bad code generation. You could have very scalar code. You could just not be utilizing your CPU like well, because like the top doesn't measure actually like
Right.
the number of UOPs retired out of the execution engine.
But here's the deal with that. The x86 is so good at running stuff in parallel. If it's endlessly stalling, there are only a handful of code patterns that will endlessly stall. The 99% of those are going to be out of memory bandwidth. You're missing in memory because you can't get it. It's not in your cache because you're accessing badly. Everyone's accessing badly. No one can prefetch. No one can get it because there's all grabbing a limited resource. The other places where you might endlessly stall, if you have machine generated code doing endless if-else trees that are randomly generated, like a random forest model, and you take endless memory jump mispredicts. But that's a very specialized case. If you add cores, you get no more throughput and you're not showing locking, 99% case, you're out of memory bandwidth, sorry.
That just reminds me of two stupid optimizations I made, but go ahead, finish up.
No, I was just gonna say I just ran the timings of my parallel thing to verify is it hyper-threading to blame, and indeed on my desktop, which has 6 cores, 12 threads, again it seems to basically top out at 6 threads. So if you run 12 versus 6, that doesn't appear to be a
Right.
performance
But
difference.
that could still be memory bandwidth, because your
Right.
laptop's memory bandwidth is geared for keeping your cores busy. Same for your desktop, which probably has a little bit more bandwidth available to it. But it's
Oh yeah, it could be. Like in this
well known
case,
for like 30 years, x86s outrun their memory bandwidth. And a way to tell is to simply write a BLAS loop where you simply do like a read to arrays and write to a third, and then run that in parallel across as many cores and see how many cores you get until your speed ups quit happening.
So I noticed that from my compiler, I mostly get my max speed at 3 cores, but 6 cores is faster because they all have L1 caches attached to them. So
And you
I
have
use
some
6.
reasonable level of cache sharing going on. I mean, sharing in your L1 caches that are working. Yeah, yeah. I'd never expect you to absolutely flatten on a 4 unless you're really out of bandwidth, but I would expect you to hit an asymptotic ceiling pretty quick, and then only creep up a little bit as you add more cores.
I think the latency also, I guess there's also big differences between like server or if you're on a desktop system, because if the latency to your DRAM is very large, then you're limited like by memory parallelism. I don't know how.
That's exactly memory bandwidth. You just said memory bandwidth.
But like your DRAM could, I mean, like for instance, your DRAM could have the bandwidth of 30 gigs per second or something, and your like you could have a single core. Technically, like a single cores between the L1 and L2 could have also 30 gigs or more. But there are these line fill buffers. At least on Intel, that's what they're usually called. And the thing is, you can only have a limited number of memory requests pending at the same time. And if the latency to the DRAM is very long, then suddenly your bandwidth is like a lot smaller. So yeah, but it's like a bit confusing, because technically if you move the DRAM a bit closer to the core, suddenly your bandwidth increases. So it's kind of also like an interplay between latency to DRAM or whether or not it's in the L3 cache or something, because it determines how quickly you can go through these line fill buffers.
If you're looking in your L3 and getting hits, you're not using memory bandwidth. And so that's a general win. And that means your problem fits in your L3.
Wait, sorry. When you say memory bandwidth, you mean DRAM, like main memory bandwidth?
Bandwidth between DRAM and L3.
Oh,
Yeah,
never mind then. Okay, forget everything I said.
Okay, fine.
Okay, sorry. Yeah, all good.
All right. Yep. That's all good.
Although someone has spent a
Nice.
lot of time optimizing the x86s for those situations. If you look at the numbers from Memcached,
Yeah.
it will often have the CPU at 100%, but it's downclocking it to only be 600 megahertz. And the temperature is low because it's not doing any work. And something has realized, oh, I'm always waiting on memory bandwidth because I'm Memcached.
Oh,
So it downclocks the thing, even though it's at 100% and the core is cool, because it recognizes.
right. But that's something that's like some OS hack or Memcached hack. Like long time ago in galaxy far, far away, when I screwed around with supercomputers and x86s side by side, it was very clear that an x86 just didn't have any memory bandwidth and you could run it out. And the supercomputer guys always whined about it because a great processor, bad memory bus, it just wasn't worth it for supercomputer work. And then you go to like H2O a decade ago, and I just hit memory bandwidth issues left and right. And if I optimized for memory bandwidth, boy, I got performance out. I didn't have any OS hacks coming in and say, clock the processor down because you're just out of bandwidth. There's no saving it. That's an interesting hack, but that's a power hack.
So the
I don't know how Memcached does that.
The two silly optimizations I did that actually worked was in my text editor. I have a special case for spaces, tabs, and new lines because they're all white space. So I noticed how hot this function was, and I just did a check if it's space or lower, because control codes are you don't hit them in text files most of the time.
They're
So
32
I just,
and under. Yes.
Yeah, so I did that one if statement, and I got a tiny increase, but I actually was able to see the increase. So yeah, that was surprising optimization. And the other one was in my compiler. When I'm generating the C backend, I need to know what line I'm on, so I can tell it this source file matches where my source file this C source file matches where my source file. So what my optimization end up being check wherever I was last, whatever I last generated, check that line, the line ahead, and maybe the line after that. And if it's not any of those three, just do a binary search. And most of the time, it's just like the line of or the line afterwards, and like it saved me like a percentage of time, like a full percent. It was crazy.
The simple code for checking for the project
Yep.
parser code for checking for white space, I just cut and paste in there, but it just says, if you're less than or equal to quote space quote, that's less than 32, less than or equal to 32, your white space.
The thing that surprised me the most is because the line numbers are just tiny. Like it has a tiny memory footprint. It's probably like insignificant to my L1 cache. Yet optimizing that made a big difference.
All depends on what else was going on. See, this is like tab expansion things here.
Oh, right. I did have another topic, but does anyone have anything else?
I just have a quick question actually to Jurek, because about Cranelift. Can Cranelift be used as a library, like a Rust crate, basically?
Yeah, that's how you use it.
Okay, cool. I see. Is it ever is it ever inefficient to have to go through bindings that you can't inline? Like, is it a problem that your code generator would not be like a library that you compile as a whole?
So at least with Rust, all the crates are statically compiled into your program. Like it doesn't do dynamic linking for Rust libraries because the Rust API is not stable.
Right, but I figured for the LLVM bindings, they.
Oh yeah, so what I do notice now is my development container runs on Arch Linux, and they only ship dynamic libraries for LLVM because, according to their issue tracker, statically linking LLVM is just not a valid use case. Like they live in a different world apparently. And I did notice when profiling that you can actually see these function calls appear from LLVM, even if, I mean, part because they also do work, but because it won't get inlined. Although that's also true, I guess, static linking, because you're statically linking a C library. Although there, in theory, you could do link time optimization. As far as I've seen thus far, the actual function calls are not really a problem, because it's not the quantity of calls that is what I'm experiencing as being slowdown. Right? I'm not calling this function a billion times, and the function itself is fast, but it's just the call overhead. It's more that I feed LLVM an ungodly mess of IR, and then I'm like, here, have fun. And it's like, yeah, sure, I'll do my best, but this takes time. And so that's where right now the slowdown is mainly self-inflicted.
Okay, that answers my question. I was curious because I did not yet use either LLVM or Cranelift. So yeah, thanks.
Okay, so yesterday I was watching a talk about YARP gen. It generates, it's basically a fuzzer for compilers. It generates a bunch of C source code, and then it will use multiple compilers to see if one is just not reporting the same results as others. And apparently it found like 200 plus bugs. And I think it might have been the Intel team, but they also like use it extensively to like test the compiler. I was just like wondering, have you guys, or it would mostly be Cliff, but have you messed around with fuzzing on like Java, like the bytecodes and the specs and all that. And I'm not even 100% sure how to implement it. Like I got the idea, but I still gotta like try it out.
Java's been fuzzed for a long time. By that happened a long time ago when it got stable. I didn't deal
How
with
is it?
fuzz generated bytecodes.
How does it? How do you like fuzz that? Because a lot of people they just like emit random source code and see if it fails or not, and that's as far as they go.
Oh, fuzzers have gotten very intelligent. So you can have fuzzers that, basically know the language syntax and then choose which piece of syntax to go emit as they go, and include self-checking in the generated code as well. Bytecode fuzzers all have to pass the verifier. It's a well-understood spec. So you read the spec and you get your fuzzer to only emit verifiable bytecodes, but they could be evil bytecodes in the sense they do stupid things that are hard to see. There are plenty of people doing like bytecode obfuscation because you had to ship the bytecodes and people were reverse compiling, and then there was a bitching and moaning about getting reverse compiled source code and there was whatever leaking. So the obfuscated whatever generators would read your bytecodes and shuffle them miserably and add all kinds of junk in them. And then they would bitch that it ran your code slower because the compiler couldn't figure out how to optimize it. But there are plenty of ways to generate this stuff. Now you have to get into the details. It's know the source code language you're headed for Java, you're headed for bytecodes, and emit only things that are going to be valid. But within that, there's an infinite number of options. Does that make sense?
Yeah, but I still don't know what's like an efficient way to generate things. From listening to the talk, it sounded like they just randomly generated some kind of like arithmetic tree, and then they will substitute some like randomly chosen operations. They'll substitute with other ones, so it doesn't overflow or do undefined behavior. But I I still it's for whatever reason it doesn't sound like it's going to be terribly efficient. And then they said like it will take more than a day to find a bug. So
So
I don't know.
fuzzing's this very useful thing. When you first run it, you find a lot of easy bugs that you then, presumably fix, and you get the asymptotic decay on bug finding for the time spent. Then somebody changes the fuzzing logic or changing how they generate it, and you get a new set of bugs for a while. And again, it goes down an asymptote, and you eventually, run out of things that your fuzzy's gonna, whatever your fuzzing technology is gonna get. Fuzzing's been around a while, and people have gotten really good at generating that stuff because it's been productive. And typically the test cases you get out are easy to reduce to something very obvious.
Fuzzing is also good for projects that have very large numbers of engineers on them. So the Chrome team has talked about the fact that when they add regression tests, that people find new ways to put the regression back, but still pass the regression test.
Yes.
But when they add regression testing fuzzer cases, that is very useful for someone who shows up 10 years later and tries to put the same bug back in a new and creative way. And the fuzzer goes, aha, I checked for these things.
That's interesting.
Oh, this reminds me of a case we had at GitLab where as part of our release process for security releases, we had this issue template that you had to follow. And it had this list of checkboxes, and people would just be like, nah, I don't need to do that, and they'll just remove it. And the system was like, oh, this is fine. So we ended up having this bot that would look at the body, and it would specifically assert that certain checkboxes were present in the exact sort of formatting, so that even if you were to like change the capitals, it would like, use the damn checkboxes, because people would work around it. Like you would tell them, follow this procedure or meet these criteria, and they'd be like, yeah, sure, but I'll change this other thing because I can get away with it. So yeah, fuzzing for that sounds like a great idea.
We had variations on that happen to us in H12 for the math algorithms and performance hacks you do to try to get something to go faster here, and you just simply add back a bug there or an incorrect math thing, and you had to have more robust tests. So we eventually settled on a bunch of things that were randomly generate a pile of numbers that has in aggregate this following mathematical property, then verify that your nth, median, log, histogram, blah, 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 generated something that was statistically significantly accurate according to the structure of the math. But if you just took like a golden data set, hey, take this and go compute the fifth histogram of whatever, you get a number out, somebody would hack something, and they get the right number because that's how they pass the test, but it wasn't doing a histogram anymore. You had
Code doesn't just get changed; it evolves under constraints.
it involved, yes,
So
yes, it evolved
if
under
you
constraints.
have tests, then you will evolve to pass your tests and have bugs while passing the tests.
And
if you have a fuzzer, it's a much more mature environment in which to evolve code.
Yes, okay,
No, I'm a
fine.
big fan of fuzzers.
Okay, I can believe it.
How do you write a fuzzer for a specific, like the Chrome team said about whatever you mentioned? How do you write a fuzzer for that?
So in the early days, they wrote a bunch of random number generator, very hand-coded things that threw HTML tags together to see what would happen. And now I believe they're using transformers to just generate random web pages that look like the training data that is the web's HTML.
You said like man, my memory's like bad right now, but you said in specific there was one bug that kept on getting reintroduced, and they wrote a fuzzer for that specific bug. Like how do you write a specific fuzzer for a specific case?
So the only one I remember is that they kept having things where if you had very deeply nested stacks, the memory consumption would just go crazy. So if you just had open anchor, open anchor, open anchor, open anchor for 16 megabytes, it would crash the browser rather than eventually saying, oh, you reached some max depth in the tree. You actually can't go more than 2 to the 20th anchor tags down or whatever the limit was. And they found that people kept breaking the logic that was enabling Chrome to protect itself from pathological things that tried to make the stack explode. But it was very easy to write a fuzzer rule that said, okay, for this fuzzer rule, we're going to do open tags only, and we're just going to throw a whole bunch of random open tags, and we're never going to close anything and see if we run into problems.
Okay, no, I understand that now. Yeah,
and then you run
easy
into a
enough.
problem and you run it again and try and minimize it and say, okay, well, what if I do it with only anchor tags? Okay, what if I do it with only the body tag? What if I do it with only, and then you realize, it's the blink tag that's the thing that is breaking this cycle detector. So if I have an infinite number of open bodies, that's fine. But if I have an infinite number of open blink tags, then it explodes. And it tries to reduce it to a minimal test case that actually shows the problem.
Yeah, that's pretty clever. Yeah.
The blink
I
tag
gotta
strikes
think about
again.
that.
But
the only one I remember was the anchor tag. It turned out that somebody had failed to account for the fact of what if you put anchor tags inside of other anchor tags, because they don't normally nest. And someone was like, I don't have to protect against nested anchor tags. They don't nest, except that
you can write it.
if
So
you're an attacker whose goal is to crash Chrome when you reload a website.
That's a terrific use case. Someone's gonna crash me on purpose.
well, but yeah, that's what that's all about.
All
right.
Has anyone tried doing I forget what it's called, where you check all the branches, like I guess is branch coverage.
Yeah.
Have any of you tried that instead of like fuzzing?
Oh, I use
So that's one of the
coverage.
ways you grade a fuzzer, is to say what is the branch coverage under different fuzzing. So you can have a reward function that says the fuzzer should mutate in this way or shouldn't mute in this way because it's getting more or less branch coverage of the code base. So that is one of the objective functions that's frequently used with fuzzers.
I must say, yeah, I've seen a white box fuzzer that was intended to keep mutating the input until he hit a certain branch and made it trigger.
Right. I will say
See,
one
I don't know how
phrase that
tools-
came from the Chrome team that stuck with me is nothing is foolproof. Fools are very creative.
That's old wisdom and still very relevant.
See, I don't know how, besides the LLVM fuzzer, because it's built into the compiler, I don't see how fuzzers can know if they hit a branch or not.
oh, they mutate the code to print something out if they've gone down the branch they want, and they put some print, when they're the area before the test to see that they got there. And if they get to the one and they don't get to the other, then they haven't got the branch correct yet.
So it's only like if statements that you can see, but you
Yeah,
can't
but
really.
you had to get to that if statement in the first place. So then there were problems to just recursively roll backwards. I started at main, I put a print in main. Oh, I got to main. Okay. Main says if usage X do blah, but I need to get somewhere buried down in some other thing. So I put a test on either side and a print on either side and a print before, and I go run my fuzzer again. And oh, I made it to this branch. I'll alter my input, see if I get to that branch. Oh, I made it over here. And then, he keeps nesting himself.
It sounds like most fuzzers would have to be part of the compiler then.
I'm talking about a fuzzer which is learning to be a white box so he can drill and get to particular tests. You can certainly have fuzzers which you teach it the language syntax and he just spews out garbage versions of C code or a Boolean code.
Right.
Just spews out garbage Boolean code by the megaton. It's syntactically valid. It'll pass your parser. It's just junk. Those have been around for a long time. That's what Aaron and I were talking about is fuzzers have been getting gradually smarter and smarter. And if you just do random code gen of Boolean code.
Black box fuzzing is hard. White box fuzzing is slightly less hard.
Yeah. Well, black box fuzzing doesn't, because you're random, you don't necessarily get with high probability certain branch cases. And you can get to a point where you just never get down some set of branches because no one writes code that looks exactly like whatever it takes to hit here. So then you want the white box thing. So you start thinking about what the input has to have a little more structure. It's not just syntactically valid Boolean code. It also has to trigger the on continue, on break, on exit triple set where you've modified variables in one or the other, and one of them's an escaping ref and blah, 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 blah. And suddenly you hit one of your corner cases that you didn't think about and the shit breaks.
Okay, because a lot of my projects, for critical code or the code that blows up most often, I'll do testing on branches just to make sure all the cases work. And usually I find that I don't have to fuzz the thing if I do all the branch testing.
The point of the fuzzer is to be stupid, be automatic, and just run in the background on your normal, testing continuous integration and have it blow up as you edit your daily life and you make a change. And oh, I'm putting memory management into Boolean and I know I need to handle this case, so I do. And I just need to do this little tweak over here to get that to work. And suddenly the fuzzer tells you, no, that little tweak over there was crucial in some particular way and you didn't realize it. So it's a nicer way to certain kinds of things that test very nicely.
Yeah.
Write yourself your own fuzzer for Boolean. Start with one that just makes a junk Boolean that says main and returns, and then say, oh, I'm going to put a for loop or randomly a function call versus a for loop versus a this versus a that. And then randomly nest, keep adding things that the fuzzer keeps generating more complicated Boolean code. You'll figure it out pretty quick.
Yeah. If you can think of a dozen no-ops and put them in randomly.
Yeah.
I should probably do that eventually. It's going to be near the bottom of my list, but I'm not too worried about quality because it's pretty high quality. I have like 90-something% line coverage, and I used to have a lot of branch testing, but
the issue you have is you don't have enough users of Boolean, so it's hard to say what your quality is other than you've passed all your users code generated.
Well, I haven't had a seg fault in like over.
You just muted in the middle of your sentence.
Oh, sounds like memory safety is done.
Pardon?
I said it sounds like memory safety is done.
Have one funny moment when the security team at Twitter was testing a fuzzer. So the first thing we did was, oh, we need some way to learn the grammar of the fuzzer and we need something to fuzz. So we decided that we would write a fuzzer grammar that would fuzz the fuzzer itself and gave the fuzzer funny config files that it itself had made. And the version of the fuzzer that was fuzzing the fuzzer crashed it immediately and just started seg faulting. We went back to them and we're like, your fuzzer is not very good at withstanding fuzzing. And they were like, huh, we've never run the fuzzer on the fuzzer before. Maybe we should go fix some of those low-hanging bugs.
Excellent, excellent. That's good, that's good.
By the way, I put in a link into the doc. There's something, I mean, it's not fuzzing related strictly, but in the Rust compiler, there are some tests for like weird expressions that test if the compiler generates like consistent compiler error messages to the terminal. Then you get like expressions like this. I put it in the chat. Like this is an actual legitimate expression. And there are also other things like crazy nested stuff.
We'll put
bunch
that
of
in the
nested
doc.
macros. Yeah, I'll do that.
What,
I also
what
put
is,
the link
what,
in there.
what language is that?
That's Rust.
I'm confused. Dot dot equal dot dot equal dot dot space dot dot. Is that
Hey,
dot
You can tell it's
Yeah.
not. You can tell it's not Lisp because there's no parentheses.
dot? Yes, I can tell it's not Lisp.
Yeah, much more readable.
I can't tell you that it's Rust though. Well, I thought AA was going to turn into have some obfuscated code. Wow.
It does have like pretty nice syntax triggers for ranges. And I guess that's what's happening here. But honestly, I don't actually know what this generates.
Well, it clearly spells the word Rust using dots and equals. But is it?
Oh, I
have
didn't
any
see that.
meaning?
Nice. Oh, I didn't see that. Cool.
Is there a good reason to support Unicode variables in a language?
Not for me.
Yes, people who speak languages other than English.
Yeah, but there aren't that many of those people.
The thing is, it's not really difficult to support Unicode. You just like once you see or like a Unicode identifiers or something like that, because once you see the upper bit, like the most significant bit of the byte turned into a 1, you just wait until it drops back down to a 0, and that's the end of your. That should be the end of the.
I disagree.
Should that be
After
the
running a
Careful
test,
down that
actually,
path.
never mind. Maybe I'm
You're talking
Are-
UTF-8, Adrian.
Are you
Yeah,
familiar with
yeah.
what makes
Yes.
a valid or invalid NTFS file name?
Oh, gee.
No,
It
I'm
used to be.
scared.
It is that it is a sequence of valid UTF-16 code points, not that it is a valid UTF character.
Oh, God.
So you can do things like the file name high surrogate, which is not actually a code point because you have to pair high surrogate and low surrogate, but is a valid file name in Windows.
Oh, I don't know.
So yeah, you can go down the path of, oh, here's my little hack that handles all of UTF-16 correctly.
I
But-
might someday get
Or
my-
handles all of UTF-8 correctly, but if you're not actually checking that it's valid UTF-8, you can run into funny circumstances like making Rust have a different string type for file paths than they do for Unicode strings, because what if the file name is a valid sequence of UTF-16 code points, but is not actually valid Unicode?
Yeah, UTF-16 should only be supported by library functions that have long names in order to dissuade people from using it. But you need it because you have to
Yes.
interop with Java and Windows and whatnot. But outside of that, you really don't want to use it. It's a nightmare.
Yes.
So
See, my problem with Unicode, specifically for a compiler, is because when they update the standard, like your code has to change, and if you're out of sync, like valid code will stop being valid, and
yeah,
illegal
but
code
you're
will.
describing situations that don't actually exist because okay, so they added an emoji and you don't support that emoji until next year when you reparse the 128 megabyte file of XML data for Unicode. Like that's okay, right? The main thing is you want English programmers to be able to code. You want Portuguese programmers to be able to code. You want Chinese programmers to be able to code, and like that part's not as hard. As long as you're not doing anything with graphics or fonts, you should be fine.
Did you see anything about switching the Cyrillic E with the Latin E? an A, another.
Yeah, like there are so many things that are in theory legal that in reality are horrifying. There's a pretty good page up somewhere talking about the attacks on domain names, for example, by using characters that look like other characters. I don't know if that's what you're referring to, but that's a pretty good read. Let me see if I can find that.
I've seen that one before too.
I
Yeah,
might
there
have
used to be a
seen this.
website at aprole.com that talked about this.
Find the link. Put it in the docs. Let me go add this one here.
I will say one of the things that I think is interesting about AA is if it can really go through and not have any keywords that are not symbols, I think that will make it popular as a multilingual language.
Oh, that's interesting. I
You know,
hadn't made that connection.
There's lots of code that I've seen that's got, Python with Chinese characters in it, but it's still if and for. Like, you can't really have the language be native Chinese. There's always going to be English words sprinkled through it in a way that I think AA might be a more nicely internationalizable language than others.
That's weird.
Wait, AA
All right.
has no if keyword?
No. Question mark colon.
Yeah, it's only the
So-
ternary.
Oh, nice.
Everyone's there's no statements, only expressions. Everything's got a value. Ternary, you can do anything you want with it.
But like, if there's a standard library, the ability for someone to just wrap the standard library with a simplified Chinese translation of the same word, that would just not be a super difficult library to maintain. And then from there
Right.
out, you can have nice, clean Chinese
Right.
up and down.
That's interesting.
See,
I-
another problem I would have with Unicode is GDB might not be happy with some of the variable names, so I'm gonna have to like think about that.
Figure out
And
what
then,
goes on in Dwarf.
yeah,
Just
I can
convert them all to Unicode for the GDB output.
yeah.
So
There's also tokens. Like I think I should just like accept like everything as like a word, like a variable, and then just like equals like quotes and just certain ones as tokens, and then it should make everything easier, even though Unicode says certain things are not part of a word. But it's just really weird, like to think about, and yeah. Like it's not going to be correct. That's what I'm saying. Like if I try to do it, it's 90% chance of it being completely wrong. I don't know how usable it is.
Yeah,
It'd
I'm
probably
kind
be
of with
fine.
Cameron. Write some piece of code generating code that reads the giant XML database and just tags all your characters.
I kind of don't want to do that.
Yeah, I didn't want to do it either. It sucks. I did it.
Like, because I'm gonna have to like verify that it won't crash GDB and a bunch of other things.
Okay, new plan. Port Cameron's code generating code that reads the XML file.
Well, does Cameron support debugging? Or does Ecstasy work in debugger?
Yeah, we wrote our own. It's just a prototype though, so don't take that too seriously.
How many days did it take to write?
One. There's a good story behind it. But it's it's easy to write a debugger if you have an interpreter. That's the
right.
So
That's the
Adrian, I
lesson.
threw some code in the bottom for
Hey,
sample
Cameron.
AA code for running a hash table, a very primitive hash table. It's kind of, the spacing didn't hit right everywhere. It's fine. It's close enough.
How do you do heap dumps? Do you just core dump and then process it after the fact, or you have something that crawls your heap and
in Ecstasy, the prototype runs on Java, so we just use Java's capabilities, the tooling around that.
Okay, AA is pretty wild. I had a look at the repository before. Source code is pretty wild. What is this What is
Can you
this
share your
symbol
screen while you're
called?
commenting on the AA
Oh
code?
yeah,
Oh.
so my
Yeah.
bad.
I'll do it. It's I threw it in the Google Docs with cut and paste errors and all. So let me go find screen share in Google Docs here. We'll see if we. And this is an old thing. It's never run because I haven't got that far.
I got a question before Adrian shares the screen.
Yeah,
It might be
Oh.
too late now.
it's
I'll
shared.
ask later.
You talking
Oh
about this
yeah, I
one?
remember that hash table.
You talking about the hat there, Adrian, at the bottom? Hat old value?
Right, this carrot, yeah, it had
Yeah, it means
whatever,
return. Return from
Ah,
function.
okay. Ah, really nice.
So that exits the put function. So code is index is call hash on key and mod it with size of the table. Call this little find helper with the table entry and the key. See if I get an entry back. If I have an entry,
Wait, what
go
is
ahead
hash?
and replace it with the new value, return the old value. If
What is this?
and then return. And if I don't have an entry, then make a new entry as make a struct with a key and a value in the next, and return a miss.
What is this hash in front of the tab at the?
It's an operator that means length, and arrays support the length operator. So it's the length of a collection, length of an array,
So you
size
can
of.
implement that for your structures or something.
I'm sorry.
So you can
Yeah,
implement
whoever
this
defines
operator.
the structure defines its hash.
Yeah, the hashtag. Yeah, that's an operator, like a mod function operator, like plus and minus and multiply and divide. It's just an operator. So everyone can define operators. Arrays have a predefined operator for hash, meaning length. But if I make a dictionary key value pair, I can define an operator hash on it, and that would give me the size of the array or size of the dictionary, or do whatever I want the operator to do.
And these, by the way, the thing with the @ is that like some kind of like anonymous record?
Yes, there are only things in the AA are everything in AA is anonymous. Nothing is named. That's an anonymous record. Yes.
But you do have, like how do you know if a record, if an anonymous record implements a certain method or
I
an
do type
operator?
inference.
Okay, all right. So you
So
start with
everything
anonymous
is
structures.
100% type inference, but you can add type annotations. So up front here on hash table is type annotated colon. Here's the KV for the type annotation. It is a function which returns a struct. So function is the first outer curlies, and then the return value is inside. It happens to be a struct. The struct is the hash table. It has defined a get and a put. And I don't need the dot, and some other stuff that you can't see, but you can see get and put. So you get a struct back. When you call hash table, you get a struct back, which supports a get and a put. That's your dictionary. That's your hash table.
Do you
Shouldn't that first curly be moved forward before the arguments list?
Which curly? So you highlight, I don't know which curly, the very first one on the type definition? Or the one
The
on the
hash table colon.
hash table equals colon.
Yes, I expected that to be equals colon, open curly argument list arrow,
These are type variables.
right?
So there's not, I'm defining a type function. The
Right?
type variables K and V for key and value. And then I return a type, which is a function which returns a struct, which takes a get, which has a key, return a value, put, and blah, blah, blah. But this is a type function. So what is the syntax for type functions in AA? It's yet an open question. Here is a sample syntax for a type function in AA.
I see.
I could have written the same thing in Java with the whole angle brackets, K comma V, you get a type language now, and then you go on and define it from there. I could write this same thing in Java with almost identically the same syntax, except I have to screw around some to get the. No, I don't. Well, you can't get the structure or return your function that returns a struct easily. So you're adding curlies. No, that's not correct. Go put that one back. Hash table. So somebody changed it and they got it wrong. So this curly is part of the value of hash table. The curly that people have anonymous camel on my screen is busily like highlighting and not highlighting. That first curly is because hash table is a function. It's a function of no arguments. So I can put no arguments. Here's a function header. It's a function of no arguments. There's no arguments in front of that dash.
Ah, okay. In that case, I agree.
Okay.
Because hash table is a function of no arguments, not
It's
a function of
no
a key and a
arguments.
value.
You just call hash table, and that's the new constructor and gives you a new hash table. In Java, you would have the keyword new, you say hash table, you say open close paren.
Ah, okay,
In
yeah.
AA, you say hash table, open close paren, because hash table is a function, you have to call it with no arguments.
Yeah,
So
it
I
is
don't have-
clearer having the arrow, despite the fact there's no arguments. It might be nice if that's optional.
It is optional. That is I took it out for being optional, but it's optional. You can have it. That's legal too.
So is this the top thing? Is this top thing like kind of like a signature, like an interface?
It's a
or
hash,
something?
it's an annotation. So hash table equals, and then you have an equals colon. When you have an equals colon, I am giving you a type annotation for hash table. What really happens here is that there are two namespaces. There's a namespace for types and a namespace for values. The type namespace picks up hash table as a type name, and I can use hash table as a type name in other contexts. Then there is a value annotation, a value assignment for hash table. It's in a different namespace. It is given the value of a function, which returns a struct. So I'll put the arrow in here. But if I use hash
Cool.
table, the type in a type context, I'll look it up in the type namespace, find it and use it as a type. And if I use a value, I get the value one. So those are two different things. I don't have to have a type annotation there if I don't want to. But I might, in other contexts, want to say, and this function takes a hash table, and I want to give an annotation for a hash table. So I can say, the map that's being supplied here is of type hash table. And then I would say, you know, map is an argument colon hash table, and I'll say it's from strings to persons, or whatever I'm going to do with my type annotations.
Okay, cool. It's like it's really, really structural then.
I haven't done any things here. So foo is type defined as it takes a map, which is a hash table that takes a string to person. And no, I don't have the right syntax because I haven't sorted out whether I wanted to do some syntax here, but this is a type annotation syntax. And foo also takes some other arguments. It takes a string name and some person P, and he's going to do something with it. But that's his signature. He takes a map and a person, and I got the signature wrong because I'm writing Java code now. And P is colon person. And actually for me, strings are stir. So I would do this. But you would get something like that as foo is I want to say a function. So let me go make foo a function here. And it's going to return me some other thing, say a person. Something like that. And then I have an implementation for foo that does whatever it does. And I could say instead, foo has this type and it has an implementation, which is whatever it's going to be. So now I've given a type to foo as a variable. The type is a function type, and then I have a function which is taking a map and a name and a P person, and it's going to do something. So the first half of that is the type, second half is the body definition. But
Are
the
the type signatures required? Because usually Hindley-Milner can infer.
yeah, it's the type annotations are always optional because it's full inference, so I can do that.
And even in the hash map definition, the key value.
Yeah, a lot of these I'm throwing in. Oh, I'm sorry. What do you guys say here in hash table?
In the hash map, the
Yeah.
key value. Usually, if you omit them, the Hindley-Milner will assign some number type or type 1 or something. Because I believe you can usually omit the type definition.
I wanted the name for hash table as a type name so I could
Yeah.
use it down below in the code here. That I wonder if I can highlight this thing in a funny way and make it obvious.
Yeah. I get it, but the type parameters. And so in the foo, you're parameterizing the hash map by the string and other type. The thing is, if the parameterized types could be a type constructors themselves, like option, like centimeters, the type definition would
I don't have the
large.
right syntax here. So in some other land of Scala, I might do like square brackets for those types.
Something. Yeah,
This is an undecided problem. Blanks don't work in complicated nested types. Yes.
Yeah, we spoke about this. Yeah.
So another one is to say I have a hash table as a type is a function, and then I'm gonna go back to adding the curly braces, which Aaron was trying to add for defining a function, but now it's a type function. And then here I want to call a type function, so I would use rounds for calling, and I hand you two types. So here is a possible syntax that would now let me nest person as having a subtype or option having more subtypes and be unambiguous about the types.
Yeah. Okay. Cool.
Okay. But I guess the original reason I came here was because Adrian said, you don't have an if statement, and there it is. I don't have an if statement, I have question marks.
It's very wild. So like, can I attempt, so I would like to try to maybe repeat some of the things in my own words to see if I understand. So this first line is kind of, it defines, like hash table is basically a type, and it takes type variables, and it defines something like its signature, like the things it has, the functions it
Lists the
has.
set of options that it supports.
And the hash table is actually a function that returns. It's kind of like a constructor that returns.
Yeah, it's the constructor.
It's a no-arg constructor.
Okay, cool. Oh, that's cool. Okay, all right, nice.
But I don't have constructors. I have.
Right, yeah.
Okay.
Because in my language I do basically something very similar, where I mean I have I have records and I have constructors, and they use the same, like I refer to them with the same word and the same syntax, but depending on the context where it's used, it refers to either the one or the other.
And then the comment to the right says this is a no-arg function returning a hash table structure.
Right. It's pretty cool, especially if your language uses a lot of lambdas, having this hash table thing be a function is kind of cool sometimes. All right.
Okay.
Thanks. I get it.
What else was going to? I was going to say down there. I highlighted the return on get here. The question mark has no colon because :0 is another default here. That's the same thing.
So have you been like experimenting with this? What is this called again? This construct.
Ternary?
Yeah, the ternary. Like, have you what's your opinion now that you've used it some time?
Well, okay. So I don't have an execution on AA because I just sorted out the last typing game last week.
But you used the Tory operator for a long time.
But I've used question mark colon in Java and C code forever and a day. I use it a lot.
And you love it, or you like it, you think it's nice?
I like it. I think it's nice. There are times when I don't and times when I do. But if I can squeeze things on one line and it's readable still, then I often will take it over other stuff. Over a series of if then else's with spread over lines. If the lines get too long, I break it up and use an if then else. If I have multiple statement pieces, parts in Java or C, I can't fold them so nicely as I can in AA, so I'll break it up.
Does AA support things like pattern matching by any chance?
Not right now. There's an obvious usefulness to pattern matching, so I intend to think about that when I get an implementation that works without pattern matching. So after sorting out last week or week before, I did the overloaded fields. I got my one out of the type info for that. I fixed my demo and whatever. Everything's working now. So I'm hacking AA in my spare time, and I'm busy doing cleanup. Like a little stuff I did for Simple, the Simple project, Debian was not on. The stuff we did for Simple looked a lot cleaner. Of course, it's got some, simpler problem and a lot newer thinking. So I'm going back and doing a lot of tech debt cleanup on AA right now.
Simple is this thing for learning how a sea of nodes works, right?
Yeah, yeah. So it has a
What do-
very simple listening implementation of how the parser interacts building the sea of nodes. I got the fancier version on AA. It's not necessary during parsing, so I'm trying to strip that out and get back to a simple version of how parsing in AA works to build the sea of nodes. That's a mid-progress hack. And, I think sometime week or so, I'll have that done, and I'll be putting in the necessary groundwork to do the overloaded field hacks, and then I'll start back on getting AA running on all my 1,000 test cases. I have what you saw last week, I have a weak execution model for the simple lambda calculus, type lambda calculus version doing overloads. That would be a very weak implementation for AA at some future date as well, but it would give me a chance to actually execute code. So you can't really tell how well these things play out so well until you code them in anger. But they type nicely. Like this example types, it's, some earlier version of the main branch in AA would type this example and tell you something about your keys and values that had to be matched right. But it's fine. All right.
I think Livo had something.
Not anymore. I probably forgot, or I'm just touching my text editor right now.
Yeah. All right. Well, we can be done.
Happy New Year.
And Happy New Year for everyone. Yes, mid-Christmas, mid-New Year. Wife and I had COVID rebound and no kids for Christmas. So sometime in mid-January, I'm hoping to have a post-COVID click Christmas. Fine.
Sounds good.
All right. I'm going to stop and we'll clean up and call it a win for now. And see people next year.
See you
All
guys.
right.
Sounds good. Cheers.
See you guys.
Bye-bye.
See you guys.
See you next
Bye.
year.